All right, everybody, welcome to the long coffee break. Thank you for attending today. We'll be talking about which humidifier technology to choose from. And with us today, we have Brent Field. He's been with Nortec for quite some time and a few other companies as well in between, worked for a rep for a certain amount of time. But he's basically my guru, my go-to guy when it comes to humidification. So while we try to know everything there is to know about all of our products here at Long, that proves difficult at times, and people like Brent have been a great resource for us over the years. Just to let everybody know, we're recording this conversation, and there will be a copy of it that'll be available, published on YouTube after the event. You're welcome to send it to others, and any feedback you have on that in particular would be certainly welcome. Thanks for attending today. This is a weekly process that we're going through. We have one for the next few weeks, and I usually send out invites to these type of conversations about a week ahead of time, just to not get them confused. But again, you're welcome to send those invitations out to your clients or to others in your circle of friends that might be interested in the content that we have to produce. And again, we're ever building that content on YouTube if you'd like to go see it. I'm going to try and silence everyone right now. If you have any questions, please type them into the chat. We'll get to those towards the end of the conversation. We'll try and keep this to a brief 15 minutes. If you do have further conversation at the end of that time, we'll probably stop recording and go into a discussion if you'd like and go through those questions that you have written since. So at this point, Brent, if I'm not having too bad of network quality right now, you can start with the presentation.
I will. Thank you very much, Jeff, and thank you everyone for joining us on the coffee break today. Yeah, so our topic today is humidifiers and how do I choose the right one? You've never had so many choices before in different humidification technologies, and it keeps expanding all the time. So it can be, maybe tough sometimes to figure out, well, what do I need? Which one is best for my application? So I thought we would talk about this a little bit today. And the first thing I usually start with is I ask a few questions that are going to help me narrow the search. Things like humidity load size. So once I start answering these questions, it helps me narrow down and kind of choose the right one. So for instance, if I have a real small humidification load, 20, 30 pounds an hour, probably going to recommend an electric humidifier, electric steam humidifier, because they're energy efficient on those smaller loads. They do a really nice job. Bigger loads, of course, it takes a lot of energy to boil a lot of water. So I'll start looking in other directions. Another type, what type of water do I plan on using? The thing about humidifiers is there's always maintenance to be done. There's no way around it. It's got to be dealt with it some way. With steam humidifiers, we boil the water. We can use potable or softened water. We have to do something to get rid of the minerals that are left behind. It becomes a maintenance issue. We could use a reverse osmosis or deionized water treatment system. Then all the maintenance shifts to the water treatment system. So it has to be dealt with somewhere. But we look at water type. That's going to help me choose what type of humidifier to use as well. We'll talk about that in a little bit too. Absorption distance. So if I'm going to put my humidity into a duct or an air handling unit, I need to know how much room I have to get that moisture absorbed, whether it be steam or be one of our adiabatic systems. Steam absorbs much quicker than the nozzle systems, for instance. So that's going to help me decide as well. And do I want my humidity to go in the duct or the air handler or directly into the space? So we have humidifiers that will deal with those as well. Tolerance control. How tight control do I need of the humidity? So am I in a lab that requires super tight control of humidity? So we have products to deal with that. If tightness of control is not such a big issue, there are other products that we could use and maybe save a bit of money. And does the building have a large cooling demand? We can help with that as well. With our adiabatic systems, again, we're going to generate 1,000 BTUs of cooling for every pound per hour of humidity that we generate. So we can actually help provide some of the cooling for the building as well with those systems. We'll talk about that here in a little bit too. So the first products that we're going to talk about here are our steam humidifiers. So down at the bottom of this slide, we list all of our steam humidifiers. So we have our EL series, that's the electrode steam you're probably familiar with. These have the disposable plastic cylinders that we boil the water. The great thing about these, very quick, easy maintenance. 5 to 10 minutes, swap out the cylinder, it's back in business like a brand new humidifier again. But these can only use regular potable water, cannot use RO or DI water. The RS series, it's another electric humidifier, but it has resistive heating elements. So with these, we can use any kind of water we want. We can use potable, softened, RO, or DI water. And with the resistive units, we have the best controllability available from our steam humidifiers. We can do super tight tolerances. So both of these, the electrode and the resistive, these are great for what I call kind of small to medium-sized loads. As the loads get bigger, maybe start thinking about gas, where we can use natural gas or propane as the energy source to boil water. So these are great for what I consider to be kind of the medium to fairly large loads. Can save the owner a lot of money in energy that way. And then the ones just to the right here, we have our central steam, we have our direct injection live steam. If a building has a boiler plant, as long as they're providing clean steam, we can inject their steam directly into the duct or the air handler. Or if the boiler is producing kind of a dirty steam, we can use our steam-to-steam heat exchanger. We can turn dirty steam into clean, sterile, atmospheric steam. So kind of some of the advantages and disadvantages I list above here. The great thing about steam is it absorbs into the air very quickly. On average, probably just a matter of inches. So those can get that steam absorbed really, really fast. As I mentioned, great for smaller loads, good proven technology. These have been around a long time. They can be quick and easy maintenance. As I mentioned with the electrode units and even our resistive units, they work really hard to reduce maintenance for the owner as well. The disadvantages though, high energy costs for larger loads. You know, if we got 2, 3, 4, 500 pound an hour loads, it takes a lot of electricity to boil a lot of water. Maintenance costs can be high. You know, if you consider replacing cylinders, although there's very little labor involved, there's a bit of material costs. And we have limitations certainly on the distance because it's atmospheric steam, limitations on distance that we can move steam from the humidifier to the duct or the air handling unit. So I use kind of a rule of thumb on that that says I can basically run a steam line 1 equivalent foot per pound per hour capacity of the humidifier up to about 50 feet. So that's kind of my rule of thumb. We can be more precise on the calculation on that, but that's a good guideline. Next, I want to talk about steam distribution just a little bit. So these are our 2 grid type system short absorption manifolds. So on the right here, we show our mini short absorption manifold. These are great for real small duct work. And on the left there is our standard short absorption manifold. This is what we use on the medium to large ducts and air handling units. So these are all designed to absorb that steam into the air very, very quickly. And here on this page, we kind of show how it works. As we bring the steam into the manifold, the steam goes up the tubes that are in this grid. In the upper left here, we have kind of a cutaway shows inside the tube. We have a whole bunch of these little stainless steel tubelets or nozzles so that we're picking up our steam right in the center of the tube. We get a very hot condensate-free steam. It's ejected out of both sides of the tube, spread throughout the whole inside dimension of the duct or the air handling unit. Gives us very, very good absorption. Another thing, we can use these for pressure steam also. When we use them for pressure steam, the header at the bottom of both of these manifolds also acts as a separator, so we don't need a separate separator component when our steam pressure is 15 psi or less. Here on this page, we have an option. I really don't think this should be an option. I think this should be standard in every application, but this is our insulated short absorption manifold. And this shows one of the tubes here that goes into that grid. And what we do is we install a stainless steel air gap or jacket around the tubes. And this is going to prevent the relatively cool air that's flowing by the tubes. It's going to prevent the tube from cooling down and making more condensate. It's also going to help prevent any heat gain into the air. It's a very, very efficient tube. Much more of the steam that we're spending a lot of money creating is going to go into the air as humidity instead of down the drain as condensate. So these are very, very good at what they do. And again, I think that these should be on every job. It's going to save the owner a lot of money in wasted water going to drain. So it's a really good way to go. Next page here, we'll talk about our adiabatic systems. So as I mentioned at the start, every single one of these humidifiers here, because we're not boiling water, we're just applying water directly to the air, just evaporate it using the heat energy in the air to evaporate the water. So these are going to cool the air as well as humidify. So we're going to generate 1,000 BTUs of cooling for every pound per hour of humidification that we generate. That might be a good thing, might be not so good, depending on what our application is. We might have to do some preheating or reheating of the air if we have really big loads, because we're going to make a lot of cooling. But the really great thing about these are very inexpensive to run. We're not boiling water. So these are very economical to run, especially when we have large loads. This is usually a really great way to go. And just kind of, I'm going to run through a few of these products down at the bottom. At the bottom left, we have our what we call our ME units, or evaporative media. So we're just running water through the media, drawing the air across to cool and humidify the air. This has a very low cost of operation. We can use any kind of water on here we want, either potable, RO or DI water. When we run potable water, we will leave minerals behind, which will build up on the media. The media will need to be changed periodically. Now with this product does not give us our best controllability, but we do have some modulation capability. We call it staged modulation. So we're turning sections of the media on and off to control how much cooling or humidity we want to generate. So it's very, very cheap to run though. The next one to the right is our high pressure nozzle system. We provide a high pressure pump supplied with RO or DI water sprayed into the air. With this system here, we can do really large loads up to over 3,600 pounds per hour out of a single unit. We really kind of look for a minimum of about 100 pounds. With this system here, these have very, very good tight tolerances. So we can turn these all the way down. We could have, depending on the size of the air handler it goes into, we could have 100 nozzles in there, and we can set it up to turn it down to one nozzle if we want to. So good controllability. It's going to be a wet section, needs to be lined in stainless steel, needs a good drain. The next one here we show, it's our hybrid system. This is our DL model. And this one here, we use a low pressure pump. So it's more energy efficient than high pressure. So we use a low pressure pump supplied to our nozzles, spray the water into the air and onto our ceramic media. So this system here has a has very good controllability. It's not quite as good as the HP is because of the time it takes to saturate the ceramic media and then again to dry it out. But it does a great job, very low cost of operation. It's the most hygienic system that we offer. We dose the water with silver ions. It's extremely good for, we have applications, pharmaceuticals and whatnot, where hygiene is really important. This is the best way to go. And then all the products here to the right of this one are our in-space various humidifiers. So with these, we're not going to put them into the duct or air handler directly into the space. So some of the advantages and disadvantages, obviously the big advantage with the adiabatic systems, very low energy costs. Low maintenance in that by far most all of these will use RO or DI water. So of course the maintenance falls onto the RO or DI treatment system. The free cooling that we talked about, capable of big loads, and the hygienics. Some of the disadvantages, if we want to call it that, most of these do require RO or DI water. We generally need more room in an air handler for absorption. So we could talk about that a little bit. Both our ME, our evaporative media, and the DL systems, we like to have about 36 inches of room within the air handler for these systems to operate. With the high pressure nozzles, the HP, we need about 6 feet of room in an air handler. So that's a consideration as well. And we talked about, due to the, large cooling that we generate, we may need to do some preheating or reheating of the air. And again, you have options, plenty of options here. With the electric, we have 2 different options for electric humidifiers. Gas humidifiers are available in standard efficiency, high efficiency, and low NOx. Live steam, use your boiler steam, or we'll make clean steam from the boiler steam. And then with the adiabatic options, high pressure goes into the air handler or directly into the space. Very good high precision. We still have some compressed air nozzles around. Those are kind of going away. Air compressors are a big user of energy. So these are, pretty much being replaced by high and low pressure pumps. Evaporative media, we got choices here too, with glass fiber or polyester media, modulating systems, and the hybrid system we talked about. We also have ultrasonics for in space. This is our lowest energy usage system that we offer. They're for smaller loads up to 40 pounds per hour, but extremely low energy costs with those. We have a few others, a rotary disc, we have mobile evaporative systems, and our newest system we just came out with is our new ceiling mounted evap system. These fit up into the T-bars and ceilings. They're totally self-contained, and it's another really economical, and these are really great for retrofits. They're super easy to put into existing buildings. And we now offer RO and DI water treatment systems. So with more and more of our systems requiring that, we can do that as well. And that's the end of my quick presentation. If anybody has any questions, happy to try and cover that as well.
Well, thanks, Brent. And I remind everyone, please type in any questions you might have into the chat. At this point, Brent, let me ask you a question that comes up quite often with all my contractors. They know the name Nortech. Who's Condair?
Yeah, so Condair is the new name for our company. Nortech, of course, most of you probably know. We've been around a long, long time. Nortech was, it's kind of a long story. Nortech was acquired by a company called the Walter Meyer Company. I think that happened somewhere around the late 1970s, I believe it was. And Condair was, or I'm sorry, Walter Meyer was kind of a holding company. They owned lots of companies. And over time, they decided they wanted to consolidate. And now they're really a humidity control company. They wanted a one name to use globally for all of the companies. And Condair was one of the brands that they owned. And they changed our whole corporation to Condair. So I think it's kind of confusing in market. All of a sudden, this Condair shows up, and who are you guys?
Yeah. Well, just everybody realized that, yeah, there's the names are synonymous at this point, although Nortech is certainly outside of any of their marketing and literature. Just to remind everyone, there is a Condair help program that we have online. We can get you access to that. This demystifies a lot of the issues that we see around humidification sizing, namely sizing or attaining the correct load for the space. You put a variety of factors into this program, and then from there you can create submittal quality printouts for your project, give you drawings as well as installation and whatnot through that program. I use it all the time, and if you want to use it on your own, please let me know. We can get you access, or go online. You can navigate to the help section from Condair, and you can sign up that way. Alternately, contact your salesperson, and we're happy to run any scenarios that you might have. Another question I'm asked, Brent, is what is the expected temperature rise that we would see across a SAMI setup?
So heat gain is not much of a factor at all. So we will get basically radiant heat from the tubes if it's not insulated. We'll get a bit of a temperature rise from radiant heat from the tubes. People think we get it from steam because we're putting 212-degree steam into the air. But the thing about the steam is the steam actually creates its own adiabatic cooling. So it will momentarily increase the temperature, but then it brings it back down to basically where it started. So the steam really doesn't affect the air temperature, but radiant heat from all those tubes in the steam grid can. Now, if we use the insulation on there, there's virtually no heat gain whatsoever.
Very good. And I often remind a lot of people, especially with the electric type of humidifiers that we have, to think of it not just as your humidifier, but think of it as your water quality filter. If you can combine both of those in, a humidifier, they say, oh, they have too much maintenance. Well, you could filter that with an RO skid, which again, RODI skids we offer through Condair. You could use that up front of a unit and have no maintenance on humidifier, but now you've moved that maintenance. So a lot of the electrode steam that we see, it's kind of nature of the beast. You have to have that maintenance somewhere. And looking at your humidifier and the electrode steam as a filtration and a humidification device, I think helps the owners understand some of those differences and those maintenance required. On a side note, the DL is actually applicable if you are using ASHRAE 170, if your local jurisdiction has accepted that, to use in hospital applications. We haven't seen that in Utah as of yet. We think that is going to come eventually, but it is such a clean direct evap that we are starting to see it used more broadly. Pharmaceuticals, as Brent mentioned, but also in some hospital applications, especially overseas. So just look for that coming in the future. At this point, we don't have any further questions, and I'll close out the presentation. I want to thank everyone for attending today. Of course, we at Long are happy to answer any other questions and specific projects that you might have. You can stay on the line afterwards if you want to talk further. But as a reminder, we do have a coffee break coming up next week at 10:30 at the same day, next Thursday, and it's the changing state of variable speed drive. So we hope you can join us for that. Thank you so much, and good luck to everyone. Have a great day.
Thanks, everyone. Mm-hmm.